Now I want to show you a whole bunch of different things today. The theme is LiDAR data, but the LiDAR data is really just the start. So what I'm going to do first of all is bring in some LiDAR data, and I'm going to show you a couple of tricks to reduce the number of points you actually display and therefore speed up your computer. Softtree's terrain module can handle up to 5 million points without a problem. That's going to change, and we're expecting to go to 64-bit pretty soon, which would boost that number to basically whatever your computer can handle. But even in the case where you have an unlimited availability of memory, you're going to slow your computer down if you bring too many points into the software. So first of all, I'm going to open up a couple of LiDAR files. Actually, file open is the wrong one. Let me start again. File insert. It's a good reason for using file insert. File insert allows me to pick multiple files. Now this takes just a second, so well, actually, I might as well show you once how long it takes. It's not a big deal. To kind of figure out where I am, I'm just going to read them in without any trimming or cropping or limiting of data location. There we are. There's the import options. Now these are LAS files. They're a lot simpler to use than text files because they have, well, it's a really nice file format. For example, here I can pick, do I want ground points or these other classified types of points, or all points. If you bring them all in, you obviously get more points, but you get some that aren't part of the ground, so you need to be careful that you don't put them in your model. We're just going to bring in the original ground, and I'll display the borders of the tiles. That's going to make it easier to see what's going on. This is better than displaying the points themselves because there's millions of them. You don't want to have to look at them and wait for the screen to redraw. This allows me to choose, the selection tab allows me to choose how many points I'm going to bring in. And we're going to come back to this, but for now, I'm just going to limit my read to 1 out of every 10 points. So it's only going to be 293,000 instead of 2.9 million points. Projection allows me to choose what projection I'm working in. I happen to know that this is in Albert's, it's from BC, and Albert's is 3005 EPSG number. So this is the projection. I don't need to understand how all these things work, but they do. So now I'm ready to read my files. The projection has changed a little bit in version 6. For example, now when I say OK here, it actually says, hey, you've just set up an incoming file to have a well-defined projection, but your current project has no defined projection. Do you want to set it? So, you know, this is kind of a little helpful tool to remind me, yes, I am reading a well-defined projection, and I will set my current coordinate system to be the same. Okay, we're almost finished reading here. The only drawback to inserting files is that it always highlights them after you read. So I do have to look at the points once and see what they look like. Not a bad thing to do in this case. You get a good introduction to how LiDAR works. This data has not been gridded. In other words, the points are scattered the way they were read in originally. Some LiDAR companies will take your scattered points, build a terrain, and then resample it on an even grid. When they do this, you lose the information that we can see here. Like, for example, I can tell that there's a lot more information being picked up by the LiDAR scanner in these corridors. They're roads. There's no tree canopy over the roads. In this area here, the canopy is so dense that the points are quite far apart. And if your points are really far apart, then you've essentially got a hole in your data. And that's just looking in the plan. When we look at the surface, you'll see other interesting LiDAR artifacts. Okay, so this is 1/10 of my data, and it's just under 300,000 points. And now I am going to make a surface. So I'm pressing on the terrain calculation button. I could have used the edit menu, would have done the same thing. These LiDAR points are quite close together. If I include all, I will get some edge effects, long, skinny triangles connecting points that are far away. So instead, I will limit the maximum triangle length to 50 meters. And I can choose, of course, to create contours. I think I'll choose a 20-meter major and 5-meter minor contour spacing. Let's see what this looks like. Great, that looks good. Let's see what it looks like in 3D. And there's our surface. Now I can rotate this fairly quickly on my screen, but your screen is going to respond a little slower because of the internet connection. If there were 5 million points in this model, it wouldn't rotate quite so quickly, but it would certainly display, and there would be no problems with lack of memory on this computer. If you're getting a new computer, make sure you get a 64-bit OS and lots of RAM, and then you'll be able to handle future versions of our software. Right now, 4 gigabytes is fine, but in the future, we'll be taking advantage of higher memory, so maybe 8, 12, I'm not sure. So the model looks good. Now, I'm going to skip a couple of steps that I've already done. If you look closely on this surface, you can actually see where the existing roads are. Here's one. You can see where my mouse is tracing there, and it looks like there's a little bridge crossing over there. That road doesn't actually go anywhere. It just kind of stops right there. Looks like they're ready to carry on the other side of the creek. Mind you, there's something going down in here, too, that could be a problem. There's a road here. And you can see, just by looking, you can see that the facets, the triangle facets near the road are nice and small. And then away from the road into the canopy, we've got bigger facets. Now, I don't have a high-quality air photo for this, but I do have a Google Earth screen capture, which I manually adjusted to line up more or less. So I'm just going to bring that into the background here. By the way, a little trick, this is completely off the topic, but these contours take a little bit of time to draw. And in fact, you can speed that up quite a bit just by selecting all the contours. So select by name, I could type in CNTR, select by layer. There's an automatic contours from model layer that gets created. Select all the contours, modify, simplify. This is a relatively new option in the software. And I'll just say, you know what, I don't care if the contour is wrong by ½ a meter. Let's take out all the points that aren't necessary so that the contours will have fewer points in them. Currently, you can see that the point selected is almost ½ a million points, so the contours themselves are ½ a million points. After I do this simplify, it's only 50,000, so that actually reduced the number of contour points by a factor of 10, and it doesn't look all that different. Nice thing about that is it draws faster. Okay, like I say, we've got a question here. Matt wants to know the density of the LiDAR data. Okay, to measure the density, it varies, right? To measure the density, I'm just going to show you a couple of zoomed-in examples, and we'll count them up. So if I Control-A select, actually, Control-A select all, that shows all my data points. Remember, this is 1 in 10 right now, but here in the canopy, I've got measure tool, points that are separated by 20 meters. So basically, you could take a rectangle here and count the points, or select the points by rectangle. You got to be a little bit careful when you do that, because the points come in clumps. Like if I select this point here by clicking on it, you can see that there's a chunk of points highlighted. In fact, 2,001 of them. So when we read in the last data, LAS LiDAR data, it doesn't put the points in single features. It clumps them in groups of 2,001. I'm not sure how that got selected, that number. So it's not that easy to select by boundary and get a point count. You kind of have to break them up. Anyway, the points in the canopy area there are around, in the gaps, are around 20 meters apart. Looks a little closer over here. And then if we look at the, let's just select all again, Control A. If we look near the road where the data is open, by the way, that 20 meters, of course, is for the thinned data, 1 in 10 points. We'll look again when we got a higher resolution read. Here in the road area, the distance between points is quite small. So between that point and that point, for example, is only 3 meters. The person who lent us this data said that it was roughly 1 point per meter in the on the average, but you can see it's quite varied. Okay, let's bring in that background file. So the background for the plan in both terrain and location allows you to add as many files as you want. I got one here called image. I'll just throw it in there. And there it is. Now I created this as a terrain. So I imported the image. I copied it from Google Earth, made it into a PNG file, read it into terrain, moved it around until it seemed to line up with the road, and I've got some roads in the background there too. I think I'll just bring them in, file insert. Oh, I don't have the roads in a separate file. I made a mistake when I was preparing here. They may be in another folder. What I'll do instead is I'll just open a terrain and copy them and paste them. Okay, terrain. So this road here, which I'll just copy out of here. Control V, paste. There we go. Okay. So this road here, this pink line, I actually traced just by looking in the 3D window and seeing where it lines up. Just recalculate to show you that it, oh, why is it not displaying? That's funny. It's in the plan. Oh well. Anyway, it's this road right here. Wait for the screen to zoom. Uh-oh. Got some slow screen updates here. There, it's finally starting to zoom in for you. At least my monitor is showing me that. Anyway, there is clearly a road running along here, and I just traced it with the mouse. In a real situation, you'd probably have shape files and so on that represent your roads or surveys. But the LiDAR data is all I needed. I could just trace right off of there. And of course, a good air photo would allow you to trace a road pretty easily too.